Okay, man, there we go. Like you know, I'm Justice Gata. Welcome to my study for understanding some of the lessons of English that I'm going to teach you. So, today we did the lesson about the power plant. Yesterday we studied some of the things about the power plant. I gave you the definition about that. I said that this is just the power plant engineering. This is the study at which we are just yes, the study of the fuels. So we are just studying the fuels, the combustion of the fuels or the fuels like that. So the heat energy that is released by the fuels, it can be the heat energy or in other forms of energy like that, uh, to be converted into the mechanical work, and then after being converted into the mechanical work, it is converted into the electrical work. So the electric energy, yes, electric energy, not electric work. The mechanical work to the electric energy. So this is what you have to study. In fact, you have to study the fuels that are used for, yes, for being converted into the mechanical work. So for generating the work, and you have to study the mechanical work. So that means you have to study giants that are used to, yes, to, I would say, to make the mechanical work for converted into electricity, so electrical energy. So this is important for us, and I gave you also some of the, I would say, some of the points about the history of the power plant. I said you that I gave you the name of James Watt, was the first the first scientist, first mechanician or something like that. And we call him a scientist first because I mean that yes, he just discovered many things, and this is not only related to the mechanical engineering, but a lot of things also. So yes, so this is an engineer. Yes, it's better. So this is the first engineer that introduced the steam engine, so the steam power plant. So he just discovered that the steam can be converted into the mechanical work. So this is thanks to him that everything is possible. And the first engine that were introduced was just the gasoline fuel engine, the diesel fuel engine, and the steam power plant. So the steam, I would say the steam engine, because the power plant was not very, yes, popular at that time. But yes, I would say the steam turbine or the steam engine or something like that. So they were working thanks to the combustion of the fuels. So before that was the combustion of the coals. Mostly that was the coals that were used because yes, we didn't that they didn't know the, I would say, the diesel or the petroleum or some things like that. They just knew that we could use the, yes, we could use the steam for generating the mechanical work. So the coal, so the coal was used as first kind of energy, of fuel energy like that. And I mean that now, yes, I talked to you also about the prime movers. So what is the prime movers? They are just the source of the power, the primary source of the power. So all machinery that provides power for performing various kinds of mechanical work is a prime movers. It is a group of machines that transform various forms of energy such as thermal, electrical, or pressure into mechanical energy. Yes, so yes, it can. In fact, this is all the machineries that convert. So they are using the fuels. So the excuse me, not the fuels directly, but what the fuels can generate like energy. It can generate is the thermal energy. At that time, we use the combustion. It can generate the pressure. At that time, for example, the power plant working with the water as source of energy, and the mechanical energy also. Yes, into the mechanical energy. So they are just using the sources for the sources of energy as fuels for converting into mechanical energy. So they are just the prime movers. The prime movers are used to convert the fuels into mechanical energy. So then there will be another machines that is used for converting the mechanical energy into electrical energy. For example, the alternator. Yes, it is a perfect example. The alternator is also used for the internal combustion engines, as you know. So it is a good example for us. So now let's talk about what we're going to study now. We are going to study the power plant. I gave you already the definition. So the power plants, the types of the power plants, we are going to study the thermal power plant and the hydroelectric power plant, the nuclear power plant, and we are going to study also the components of the nuclear reactor, the different types of nuclear reactors also. So these 5 lessons will be our uh, yes our studying for today. So first of all, when we talk about the thermal power plant, what we are going to talk about, we are going to talk about the combustion first, the combustion and the releasing of the energy provided by the combustion. So then there will be so many forms of energy. Uh, so many types of sources energy. So you have the coal, you have the petroleum products, for example, the kerosene, the gasolines, the diesel fuels, and so on and so forth. But you can even use also the molten metals. So it depends. In fact, the multimeters is also used for different types of power plants, but in this case also it can be used because we use the combustion of our metals to convert that into mechanical energy. So this is something that is very interesting because the forms of energy can be even everywhere. For the coals, not only the coals that we can just get from the rocks, but also some of the coals that are just yes, from the wood, for example. From the wood, we can just brew the coal. So we can use that also. And for the gasoline or the diesel, not only for the cars, but also for the power plants. And yes, the power plants, I mean that with that at that moment, there will be a lot of emissions, exhaust emissions at that time. So it will be very complicated, but I mean that we are just making it sort of uh, in fact, because I can, in fact, just because of the fact that it will generate the carbon dioxide, it is important to control this carbon dioxide. So this carbon dioxide can be also used for making again the yes, used as fuels again for making the mechanical work to convert that into electrical energy. So these are just some of the ideas that we have like that for you. This is a system that we use in Italy. In Italy, there is just yes, a little startup like that. So they are just making in sort of the carbon dioxide that is just coming through the air like that is just injected into a dome. Then after that, the yes, I would say just that it will be stored as liquid. So somewhere in some of the things like that, some of the bottles like that, the weight bottles, of course. So weight bottles will store the carbon dioxide just in one place, and then after that we just compressed. So we are gonna just again we are gonna heat again this liquid carbon dioxide to making rotating our turbine or our alternator or some things like that. So this is a great principle, and for us it can be used also at that time. You are gonna use not only the fuel of the mountain or even of the coal or the gasoline or some things like that, but you are gonna use also what will be released. Yes, it is really interesting as you can understand. And the hydroelectric power plant. Yes, so this is just a power plant that is using the water as sources of energy. So the difference with the thermal power plant is just that This is about the pressure and the kinetic energy of the water that will make the mechanical work. So that will make rotating the turbine. So yes, it is another, and for the thermal power plant, this is the steam that is just released, the heat energy that is released from the combustion of some of the sources of energy, some of the fuels like that. I already quoted that. I quoted the coal, the gasoline, the diesel, and so on and so forth. So it is really important. And this is a hydroelectric power plant. And for the nuclear power plant, they are just using and yes, for this one I have to give some of they are using the nuclear energy released from radioactive materials due to fission reaction is utilized to heat the water and convert it into superheated steam. Yes, so they are using the radioactive materials. When we talk about the radioactive materials, we talk about the uranium, the plutonium, and so on and so forth. And yes, just the heat energy that is released from these is just utilized from the friction of these types of materials, the friction reaction of these type of materials is utilized to heat the water and then convert to superheated system, like they say, superheated steam. So this is a superheated steam that will make rotating our turbine to convert that into electrical energy. The rest of any electricity generation process is similar to steam power plant, as discussed in section 1.3. The main problem is careful handling of radioactive fuel used in nuclear reactor. Yes, this is the factor of handling these types of materials because, like they say, the radiations from nuclear fuel are very harmful and dangerous for human beings or even for any beings in this earth. So this is important to take into account. And what we have to do for just protecting ourselves from these nuclear radiations, this is um, to use the shielding. Yes, therefore, complete shielding of nuclear reactor is required. So the shielding, there is some of the clothes that you are going to talk that will protect us from the radiations of the nuclear materials. So yes, it is really important to take into account when you are handling with these nuclear reactors. So yes, this is the same principle with the steam, but what you are using as a source of energy, this is the excuse me the yes, this is about the plutonium, the uranium, so the nuclear materials like that, at which the friction reaction of this, the friction reaction of neutrons of these uh, materials generate a heat that will be used to heat the water, and then after heating the water, that will be converted into steam. Yes, into steam, and then the steam will the steam will be the heat energy that will be used to be converted into mechanical work. Then after mechanical work, it will be converted to electrical. So now let's talk about the components of the nuclear reactors. You have the fuel. The fuel will be the uranium, the plutonium, and another types of uranium because there is two types. It depends of the numbers of neutrons. So to release the heat energy, yes, and is formed. pH is formed due to absorption to neutron by U without fission. Yes, in homogeneous reactors, the fuel, uranium, and moderator are mixed homogeneously and used in forms of rods and plates in the reactor. And you have also the moderator, the control rod, the shading, the reactor vessel. Yes, the moderator will be the water that will be used. In fact, it depends on the types of nuclear reactor that you are going to use. So the moderator is a material which is used to reduce the kinetic energy of fast neutron. Yes, because the neutron are just moving through the yes, through the combustion chamber, I can say, no, to the fission chamber very quickly. So it is important to reduce their just their kinetic energy within the fraction of second to maintain the fission chain reaction. We have the H2, the G2, N2C, heavy water, and BE are some important moderators. Yes, we have the G hydrogen, the G nitrogen, uh, and the carbon with the heavy water. Mostly, this is the heavy water that we use than these types of bodies. And the ordinary water is used to moderate as moderator only with enriched uranium. Enrichment is a process to increase the amount of uranium. Whereas graphite, heavy water, and beryllium can be used with natural uranium. Yes. The major characteristics of moderators are ability to slow down neutrons, resistant to corrosion, high melting point, high chemical stability, and non-absorbent of neutrons. Yes, some things like that are very important to be. And we have also the control rod. The function of the control rod is to start the nuclear chain reaction when the reactor is starting from cold to maintain the chain reaction as TG state condition and to shut down the reactor automatically under emergency conditions. Yes, this is the control rod. So this is like they said at a low temperature. This is to start yes it's just to start the nuclear chain reaction because when you start this reaction it will generate very yes a very big explosion. So this is important to maintain that in just uh, decreasing the temperature when the nuclear reaction occurs to maintain the chain reaction as steady state condition and to shut down the reactor automatically under emergency condition. The material used for control rods must have very high absorbent capacity for neutrons. The common materials used for control rods are excuse me, boron, and hafnium. You have also the shading. Neutrons, gamma rays, and all other radiations are efficiently absorbed by the concrete and steel. The inner lining of the core is made 50-60 centimeter thick steel, yes, plate, and it is further thickened by few meters of concrete. The lining of steel plate absorbs these rays and becomes heated but prevents the adjacent wall of the reactor vessel from becoming heated. The thermal shield is cooled by circulating water. Yes. And we have also the reactor vessel. It consists of reactor core, reflector, and chip. It also, yes, the shading is very important because it have to absorb the neutrons, the gamma rays, and all the radiations. Yes. So the inner lining of the core is made of 60 to 50 to 60 meter. Yes, and this shield also is cooled by the circulating water. So the moderator, the reactor vessel. It consists of reactor core, reflector, and shield. Yes. It also provides the entrance and exit passage for directing the flow of the coolant. Yes, this is very important because the coolant, as I said, this is the moderator. If the fission reaction is very, because of the fact that the fission reaction is very dangerous, you have to just to allow the complete, a very flow circulation of the moderate of the coolant. It should have withstanding capacity of more than 200 bar. Yes, and the withstanding capacity about the pressure for maintaining the fission reaction. At the top of the vessel, a hole is provided to insert the control rods. The reactor core is generally placed at the bottom of the vessel. Yes, it is. This is about the reactor. Yes. Yes. So these are just the parts, the components of the nuclear reactor. You have the fuel, you have the moderator, you have the what again? Excuse me, the moderator, the control rod. Yes, the control rod, the shading, and the reactor vessel. So these 5 units. I already explained you. So I mean that. So now let's study the nuclear reactor, the types, the different types of nuclear reactors. So we have the pressurized water reactor. And this is the first reactor that I explained at the definition. Just the fact that it will use the friction reaction to generate the nuclear energy, and this nuclear energy will be used to heat the water, and then the water, uh, so the steam from the heating of water will be used to be converted into the mechanical work, and then the mechanical work will convert that into electrical work, electrical energy. This is the same principle. We have the boiling water reactor, and the boiling water reactor in which uranium is used as fuel and water is used as coolant, and moderator like uh, PWR, except the steam is generated in reactor itself. Yes, so the fuel will be the uranium directly. So at this moment, we will not use the nuclear energy that is. So we are going to use the nuclear energy just directly for yes for making the mechanical work. And the heavy water cooled and moderated can do. So Canadium, deuterium, uranium reactor. So this is heavy water cooled and moderator can do. And moderated, excuse me, moderated can do reactor. So in this reactor, natural uranium is used as fuel and heavy water is used as coolant and moderator. Yes. So we use the heavy, like the name said, use the heavy water as the coolant and moderator. And the natural uranium is used as fuel. So yes, it is really important to take it over. The gas cooled reactor. The reactor is cooled by the gas, and the heat carried away by the gas from the reactor is either used for generating steam in secondary circuit like PWR, or it can be directly used in gas turbine. So the gas cooled reactor. So the reactor is just cooled by the gas, like they say. The gas will be the moderate, and the heat carried away by the gas, yes, from the reactor is either used for generating steam and secondary circuit like PWR, and or it can be directly used in gas turbine. Yes, in fact, mostly this is used to moderate, like they say, because the temperature is very high. At this moment, you are going to use a gas that will be able to cool uh, yes, to be a very at a very high temperature very easily. I would use even the nitrogen if it is possible. I can talk about the nitrogen. Yes, the nitrogen had also have these capacities. So as gas cooled reactor, I will talk about the as gas moderator. I'll talk about the nitrogen. And you have the fast breeder reactor. Yes, there is not any moderator, like I said you. So it will work very fastly without any moderator. The casing is covered with a thick blanket and chiclet chilled fertile uranium. The injected excess of neutrons are absorbed by the fertile blanket and it converts into fissile material. The heat produced in the reactor core is carried away by liquid metal. The major difficulty is to remove the large quantity of heat from the core as the power density is very high. Yes, 430 kilowatt per liter of core volume, which is 40 times greater than CANDU type reactor. Because of the fact that there is not any moderator, and the 30 is 13 times greater than the BWA and 20 times greater than gas cooled reactor. Yes. So it is very high, as you can understand. So yes, this is the end of our lesson. I hope for you that you understood everything about that. And yes, and this was the lesson about the power plant. Yes, I said you that the thermal power plant um, is just the power plant that is used for just I would say the calorific value of the combustion of the fuel. So if this is high, it will be used. And then for the hydroelectric power plant, this is the water, and the nuclear we are using the yes, the materials, the radioactive materials, um, and then it will be used to the energy that is releasing from the fission reaction of these materials will be used to heat the water, and then the water will produce some steam that will be converted into mechanical energy. Then the mechanical energy will be converted into electrical energy. Yes. So that was the lesson of today. So see you tomorrow for another lesson, and thank you for listening. All right, thank you.